Welcome to the Innovation Series, where I will demonstrate building complex technology from scratch. In this video, we will revisit our tabular documentation. We will add a contract or requirements table, and you will learn the first skill set to manage consistency by adding automation in the spreadsheet. Let's review our journey so far. We began by defining the primary concept, a generic description of the device's function and operation. From this, we identified the entities that interact with the device. Subsequent to that, we developed the activities chain, which further details interactions in terms of function and operation to achieve a particular goal. This activities chain consists of individual activities, each representing a specific function and operation. Each activity has a subject, which aligns with the entity derived from the primary concept. Following that, we applied a formula to derive contract requirements from the activities chain. These contract requirements consist of individual requirements, each mapped directly from an activity using a specific formula. Now, consider the complexity of maintaining consistency throughout this process. Managing documentation itself becomes a challenge. Each requirement must remain consistent with the related activity and entity. If an entity's name changes, that change must be reflected in the corresponding activity and requirement. The lower layers, requirements, must always align with the upper layers, activities and entities. To address this documentation complexity, we introduced automation. Our documentation should be structured so that any change is automatically reflected across all related elements. Automation not only ensures consistency, but also improves efficiency in managing documentation. Previously, I demonstrated how we used Google Sheets to document complex technology. Now, I'll introduce a technique to ensure automatic consistency across multiple tables when entering data. Let me demonstrate it to you. Let's begin by creating a new table called the Requirements table. I'll add a new sheet and name it Requirements. This table will have 3 columns, one for the requirement ID, one for the requirement description, and one for the activity ID. We can populate it with the requirements we've previously derived. Since each requirement is linked to a specific activity, establishing a connection between the columns is straightforward. Requirement 1, or R1, is linked or connected to the activity 1, or A1. They are connected because requirement 1 is derived from activity 1. Requirement 8, or R8, is also connected to the activity 8, or A8, because requirement 8 is derived from the activity 8. With the addition of this new table, you may notice an increase in complexity. As complexity grows, automation becomes more important. For instance, if the entity name changes, say from user to operator, the description, which is hard-coded, would need to be manually updated across all entries. This can become a tedious task. Let's see how it will affect the activity chain table. This table consists of 8 entries. The user is referenced by column description and the owner. Imagine that if due to one small change, then we have to modify all these entries where the user was referenced. If it is done manually, then maintaining consistency will become a labor-intensive task. Manual process should be avoided because it is prone to error in the execution. As the system grows in complexity, there could be hundreds or even thousands of requirements linked or connected to other definitions. Connecting the traceability or checking the consistency item by item is not feasible. Automation becomes an essential tool for documenting complex systems. For that reason, I'll demonstrate a simple yet foundational example of how to add automation to manage consistency between the requirements, the activities, and the entity definitions. This way, if the name of an entity changes, the related requirements and the activities will automatically update to maintain consistency. Let's use Activity 1 or A1 as an example. Suppose the entity name in the Entities table changes from user to operator. This entry is located at row 2 and column B. We can reference this entry by using the table name and its location. If we type entities, B2, then this entry will always reflect the most recent value of B2. For instance, in the owner column, we can insert entities, B2. After inserting the formula, then any changes in the entities table of B2 will automatically be reflected in the owner column. If B2 changes from user to operator, then this entry will also automatically be changed from user to operator as well. In this way, we maintain consistency automatically without manually modifying all entries one by one. Now, let's shift our attention to the description column. The owner column is quite trivial to handle because there is only a single entry. However, the description column is more than a single entry. It consists of a sentence in which one of the words refers to the other entries. As for the description column, we want to modify a single word only, but keep the entire structure fixed. In other words, to maintain consistency, we want to set automation to only a particular word. I will introduce you to the operator ampersand. The ampersand is used to combine formula and text. In this case, we want to set user as a formula, the word the as a text, and the sentence transfer mechanical energy to catapult as a text. So, if we add it into the spreadsheet function, first we add the word the as a text, then we add ampersand, then we add our formula that is entities, B2, then we add text again, transfer mechanical energy to the catapult. Do not forget to add the operator equal in the beginning to indicate that this is a spreadsheet formula. If we press enter, then now we have a sentence with a word that refers to the entry B2. With this formula, every time we update the value in the entry B2, then the most recent value will be reflected automatically here. This is how the automation was done to manage consistency between multiple tables. If you want to be more complete, then we can also refer to the word catapult in the entry B3. If for any reason the word catapult changes into device, then it will be reflected in this description of Activity 1 or A1. To do that, we simply break the text, transfer mechanical energy to the catapult, into text, transfer mechanical energy to the, add ampersand operator, add formula, entities, B3. If we press enter, then we have a sentence that is always consistent with the entry B3 in the entities table. Now, we manage consistency automatically both in the entity user and the entity catapult. This technique is simple but powerful and can be extended to all entries to manage entire consistency among multiple tables. Now, you can apply the same method to update all activity descriptions and even the requirement table for consistency. I'll conclude this simple demonstration here, as it effectively captures the essence of automation. As complexity increases, we'll explore additional automation techniques to keep the documentation of complex systems manageable. For now, this level of automation is sufficient to ensure consistency across all tables. Let's move on to the next lesson. where I'll share the story of how the first device was implemented.